Hello everyone, welcome back to Life Technologies YouTube channel, and thank you for watching and supporting our channel. So kindly, if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button to support our channel and also to stay tuned for more upcoming videos. So today we are continuing with our Nokia Lab simulation series, and in this episode we will be discussing how to implement OSPF for Nokia routing devices. So we know that OSPF is a very common routing protocol. It's a link set protocol similar to SIS, and it's an IGP, the Interior Gateway Protocol, and it's commonly used on service provider network and even enterprise network to ensure that we can dynamically exchange the link state information and be able to learn the routes dynamically instead of doing the static way. So you need to understand how to configure OSPF on different vendors, how to configure and troubleshoot OSPF on different vendors. So previously we have demonstrated how to configure OSPF on Huawei routing devices and how to implement different advanced features of OSPF on Huawei routing devices. So we'll be doing the same on Nokia. And if you haven't watched the video on Huawei, and if you are interested in learning how to implement OSPF on Huawei routing devices, check it out on our Huawei Lab simulation series. So in this episode, we are discussing how to implement OSPF for Nokia routing devices, and this is the topology that we are using. You can see that we have different routers. We have R1, R2, R3, and R4, and they are all divided into different areas. Remember, OSPF had the concept of areas. So we have the backbone area, area 0, and we have R2 and R3 acting as the ABR, the area border routers. And then we have R1. R1 is in area 1, and R4 is in area 2. So we'll be discussing or demonstrating how to configure this OSPF protocol or Nokia routing devices. And our configuration will be step by step. So we'll be configuring the interfaces, configuring the OSPF protocol, and checking how to troubleshoot OSPF or Nokia routing devices step by step. So from this setup, the first thing that we need to do is to configure the names for the routers. So we've demonstrated this before. I will do it again just for you to be familiar with it. It's configure system name. This is on R1. So this is how we configure the system name. Configure system name R1. On R2, we'll do the same. Configure system name R2. And then on R3, we also have to configure the system name. Configure system name R3. And then finally on R4. So let me just expand this. On R4, we'll configure system name R4. So we have the system name configured. The next stage of our configuration is to now start configuring the interfaces on these routers. So we have the loopback IPs. You can see that from this topology setup, we have different IPs assigned for the loopback or the system IP. On Nokia, we call them the system IP, the management interface. So we have the system IP configured, assigned. We have 1.1.1.1 for R1, 2.2.2.2 for R2, 3.3.3 for R3, and 4.4.4.4 for R4. And then we have the point-to-point IP address assigned also. So between R1 and R2, we are using 12.12.12, and the others are also indicated between R2 and R3 and between R3 and R4. So on R1, if we check the interfaces, if I run show system interface, show router interface on R1, you can see that we only have the system interface configured, but we don't have any IP address assigned. So we need to configure the IP address for R1 for the system interface, and also configure the point-to-point interface between R1 and R2. So we'll start by configuring the system interface. So it's configure router interface system. I can do info. You see, we only have the no shutdown command, so we need to assign the IP address of 1.1.1. Mask is 32. That is it. And then we need to configure the interface between R1 and R2. So it's configure router interface to R1, this should be to R2, info. So we need to start by giving it a description. We just give it a description to R2, and then we need to assign addresses. So it's 12.12.12.0, mask is 31, info. So we have the configuration, we have assigned the address, we have the description, the interface is not shut down. The final part is that we need to bind the port. So we can check the port that is connected to R2. If I show system LLDP neighbor, you can see that we have this port connected to R2 from R1 to R2. So you need to run the port command and bind the port. So if I do info, you can see that we have the address, we have the description, we have the port, and it's not shut down. So I can show router interface. Now we have two interfaces configured with IP address, and all the other parameters are configured okay. So we can do a similar on R2. R2 we also need to, we have configured the system, we need to configure the system interface. If I run show router interface, we have the system interface, but no parameters are configured. So we'll start by configure router. I will do all the configuration under this hierarchy. So if I do info, I have the system interface, no IP address assigned. So I will do interface system info. I will assign an IP address of 2.2.2, mask is 32. Then info, so we have the address assigned, exit. We need to also configure the two other interfaces. So I will configure, I just need to run the interface command. Interface, will start with the interface to R1, give it a description to R1, and then assign the IP address of 12.12.12.1, mask is 31, info. And the final part is to bind the port. So I can run show system LLDP neighbor. You can see that this interface is connecting to R3, C1 is connecting to R1. So I just need to run the command port, and then info. So we have the port configured. Can use the command info again to see the configuration that we have. So we have the interface configurations, interface to R1, and the system interface. Can show router interface, and these are the interfaces that we have and the parameters configured. So we go to R3. On R3 we need to do the same. We need to configure two interfaces, two logical interface connecting to R2 and to R4, and then we also need to configure the system interface. So I can start by show router interface. We see what is configured. We have the system interface configured, no address assigned. So I will start with configure router, going to this hierarchy info. We have the system interface. I'll do interface system. Remember, sometimes you can configure these parameters at once. You don't need to go into the interface system hierarchy. I can just run address. This is 3.3.3, mask is 32, and that is it. So if I do info again, you can see that we now have address assigned on this interface. So you can use one command, or you can go into that hierarchy and configure the necessary parameters. So we also need to just extend this one so that we can see it clearly, the address assigned. So we need to configure the interface going to R2. So I will run interface to R2, and then we need to assign the address of 23. I think we forgot to configure R2 with another interface. We'll go back to it. 23.1, mask is 31. And then we need to give it a description to R2 info, and then bind the port. So I can use the command show system LLDP neighbor to see the connection. So we have C2 connecting to R4, C1 connecting to R2. So we'll bind the port going to R2. This is C1. Info, we have all the configurations. and then we need to configure another interface going to R4. So I will run the command interface to R4, description to R4. Always remember to give proper description for your interface configurations, and even on the ports you always have to give proper configuration as per the standard requirement of your company. So once you've done the configuration, you need to assign the address. So its address, this is to R4. We are using 34.34.34.0, mask is 31. And then we need to bind the port. So show system LLDP neighbor again, and we do the port. This is C2 that is connecting to R4. Info, exit, check the configurations. We have the interface to R2, we have the interface to R4, and we have the system interface. Show router interface, we have the three interfaces, and they are now up, admin app and operational app for version 4 addressing. So let me check R2 again. Show router interface, we forgot to configure one interface, so we need interface to R3, interface to R3, info. So we'll give the address of 23.23.23.0, mask is 31, and then description, it's to R3, and we need to bind the port. So show system LLDP neighbor to get the port, then I will copy the port. This one is connecting to R3, this is C2. Info, so we have the necessary configuration on R3, on R2. We have the interface to R1, interface to R3, and the system interface. Show router interface, we have the parameters. They are admin app, they are also operational app for version 4 addressing, and you can see the ports. So we can now finish configuring R4. So R4, we need to configure router. We start with the interface system and assign info. We'll assign the address of 4.4.4, mask is 32. Info, that is okay. We'll configure interface to R3. So it's interface to R3. Description, give it a similar description to R3. And then assign the address of 34.34.34.1, mask is 31. Info, we can bind the port, show system LLDP neighbor. We have the ports. So it's port, and then it is this port that we need to bind. So info, we can verify the configuration, exit info again. We have the configuration for the interfaces. Show router interface to verify, we have the two interfaces. So we can try to ping the point-to-point interface between these two routers. So on R1, if I try to ping 12.12.12.1, I'm able to ping. On R2, I can try to ping 12.12.12.0. I'm able to ping, use Control C to stop it. And I can also ping 23.23.23.1. We are able to ping. Then on R3, we can try to ping 23.23.23.0. We are able to ping, and then 34.34.1. 34.34.3.1 we are able to ping, and finally on R4 we can also verify that we are able to ping. So I relog into R4, show router interface, and try to ping 34.34.34.0. So we are able to ping, which means our interface configurations are all okay. So the next stage of our configuration is now to start configuring OSPF. Remember, when you configure OSPF, there are some parameters that you need to configure. You need to configure the OSPF instance that you are configuring on the router. So we can use, and remember the instance is always locally significant, so you can run, we'll be configuring OSPF instance 10 on all the routers, and then you need to specify the area. And once you have configured the area, on Huawei we used to advertise the networks that we need to be advertised in OSPF. On Nokia, we'll be activating the interfaces under the OSPF hierarchy. So to start us with, we'll start with configuration for R1. So how do we configure OSPF? I've mentioned that the first step is we need to configure router in this hierarchy. That's where we configure the OSPF configuration, OSPF, and then you can see that we can specify the OSPF instance, and we can configure a maximum of 32 instances on this router. So I will be configuring instance 10. Then one good practice is always to configure the router ID. So router ID will be the system IP 1.1.1 info. This is what we have so far. We need to unshut down the process. So we have the router ID, we have unshut down the process, and then we need to configure the areas. So for area configuration, I will specify R1 is in area 1, so I will specify area 1. Then info, and we now need to activate the interfaces. So I will run interface system, that is it, exit, and interface to R1 to R2, info, exit. We check the OSPF configuration again. So we have configured OSPF process 10. This is the router ID, this is the area, and then we have activated the two interfaces under this OSPF instance. So that is it for R1. We need to go to R2. On R2, we are already under the router configuration. So we just need to OSPF 10, router ID 2.2, and then we have we need to unshut down the OSPF instance, and then we have 3 interfaces that we need to configure. So we have the system, and the interface to R3 will be in OSPF area 0, the backbone area, because remember R2 is acting as the area border router, so it's connecting the 2 areas. And then the interface to R1 will be in in area 1. So we'll start by configuring area 0. So it's area 0, and then we need to specify the interface system, exit, and also the interface to R3, exit. Then we do area 1 configuration. I need to exit first. Area 1 interface, it's interface to R1, info, exit again. So we have this OSPF configuration, we have 2 areas. Let me expand this. So we are configuring OSPF instance 10, router ID, area 0, and area 1. And we have activated the interface as required or as per the planning. So we can move ahead to R3. So on R3, we configure router. You can do info to see what we have so far. On R3, we are configuring area 0, the backbone area, and area 2. So R3 is also acting as the ABR. So I will run the OSPF 10, no shutdown, and then router ID is 3.3.3, and then we can specify the area. So we'll start with area 0. We need to advertise the interface system, and then we also have interface to R2. So it's interface to R2, exit, info, exit. We need to configure area 2. So I will run the command area 2, and then we need to activate the interface to R4, exit. So these are the configuration that we are doing for OSPF on R3. We have area 0 with interface system and to R2, and then we have this area 2. So finally, we need to do the configuration on R4. So on R4, configure router OSPF 10, router ID 4.4.4. It is area 2. Let me undo shutdown, no shutdown. It's in area 2, interface system, exit. You can configure many other parameters under this is the system. Maybe you need to configure the network type, you need to configure the priority. But remember, in this setup, we are just demonstrating how to do the basic configuration. And in our upcoming videos, we'll demonstrate how to configure the advanced features like the DR, BDR, election, how to configure the virtual links, how to configure different areas, the stub, the not so stubby, and even how to do the authentication and many other things that you need to configure when you are handling OSPF in production network. So this is interface to R3 info, exit again, info. So we have the OSPF configurations ready on this router. So the final stage of this lab is to now verify that our peering status or our OSPF adjacent these are up and we are able to learn routes via OSPF. So I will start with R1, show router OSPF neighbor, OSPF 10 neighbor. You can see that on this router we have a peering to R2. We can do detail to see more details about it. We have the neighbor IP address, we have the local IP address, the area ID, the DR, the BDR, the neighbor state is full, priority is 1, and many other. The uptime is 3 minutes. We have the GR helper not helping, and we have the counters, the bad neighbor states, bad packets. We don't have any bad MTU, none. We can see that last event time, the options. So we can get all these details when we are using the show this command, show router OSPF 10 neighbor detail. So you can also show the database. So it's show router OSPF 10 database. You can see that we have the LSAs, we have the router LSA, we have network, we also have the summary LSAs on this router. You can also show router interface, show router OSPF 10 interface. You can see that we have this interface. You can do detail. You see the details configured for this interface. To R2, you can see the network type is transit, operation state, designated router, and many other details that you can check when you are configuring and running OSPF in your network. Total TX packets, TX hellos, DBDs, LSRs, LSU, the acknowledgement, the TX failures. So you can check all these parameters when you are troubleshooting your OSPF configurations on Nokia routing devices. So we can check on R2. So on R2, show router OSPF 10 neighbor. We have the peering relationship to R1 and to R3. You can do detail. You see the detail parameters configured for this peering session. You can show router OSPF 10 interface. You'll get the detailed information about the interface. Use the detail command to get more details about the configured parameter, the priority, the packets exchanged, and many other small detail that may help you when you are troubleshooting OSPF. We can show router OSPF 10 DB. You can see that we have this LSA, the router, the summary, the network LSAs exchange between the different areas. Remember, R2 is our area border router, so it will have LSAs from different areas. Then R3, show router OSPF 10 neighbor. We have two neighboring relationship, one in area 0, another one in area 2. Again, you can display the detail. We can get the interface. So remember, you can always use shortcuts. For example, I've already typed the command show router OSPF 10 neighbor, but then I want to clear the word detail and neighbor so that I can use it to display the interface. Remember, we have had an episode we discussed the detail, the shortcut that you can use. Maybe if you watched it, you can comment in the comment section which shortcut I'm currently pressing on my keyboard to clear the word detail and neighbor. So I can just clear it and then use the interface. And even sometime I can clear the whole line. So which shortcut am I using when I'm clearing the entire line, as in this case? So you can use the shortcuts to easily navigate the CLI on Nokia. So we have the two interface. You can use the detail command. You can use, let me use my shortcut again, interface and then detail. If you remember the shortcut, just comment it in our comment section. And if you haven't watched the video on shortcuts that you can use when navigating the CLI, you can check it out on our series. So we have the details. And then on R4, we can also show router OSPF 10 neighbor. You can see that we have one neighboring in area 2. You can show router OSPF 10. Let me use my shortcut again. OSPF 10 interface. You have the interface. You can do the LSDB, you have the router, the summary, and the network LSS generated from different routers and exchange between there. So this is the link state information that has been exchanged between the routers in different areas. So the final part of this is now to verify that we are learning the OSPF route. So we can show router route table. You see that we have the routes. We have LAN OSPF routes. We have local route, the directly connected routes, but we are able to get the routing information from OSPF. I can try to ping from R1. I can try to ping R4. So I have the reachability. I can show router OSPF 10 and just specify the routes. So I have the routes LAN from OSPF. I can also, let me see, show router route table and specify the protocol OSPF. I'm able to see the route that I've learned via OSPF protocol. So on R2, we can also verify the same. Show router route table. We have the routes learned via OSPF. Show router route table. Protocol OSPF. We have these routes learned via OSPF. On R3, we can do the same. Show router route table to verify that we are able to learn routes via OSPF. Show router route table protocol OSPF. We are getting the routes. On R3, we should be able to ping 1.1.1. We are able to ping. And finally on R4, show router route table. Show router route table protocol OSPF. So we are able to get the routing information from different areas via OSPF. So this one verified that our OSPF configuration are okay and it's working fine between the different area. The ABR is able to advertise routes from different areas, area 1 and area 2, and all the information is propagated in our OSPF domain. So this is it for this lab demonstration. Remember, let me just again show you the OSPF configuration. On one of the routers, it's very easy. Info, You just need to configure the router ID for the basic configuration. You need to specify the areas and activate these interfaces into the respective areas. And then you also need to run the no shutdown command globally to ensure that you are enabling the OSPF instance on this router. And once you've configured OSPF, you can use different commands: show router, OSPF neighbor, show router, OSPF interface, show router, OSPF database, to verify that you are getting the required information propagated via OSPF. So this is it for this lab. I hope you have enjoyed the session. If you have any question, leave it in our comment sections. And again, please remember to hit that subscribe button and stay tuned for more upcoming videos. So in the upcoming videos, we'll be demonstrating some of the advanced features of OSPF, how to control for example, the DR and the BDR or Nokia routing devices, how to configure virtual links, how to configure different the different area types, like for example the NSSA, the stub area, not so stubby. All those will be demonstrated in our upcoming videos. So just stay tuned, click that subscribe button and stay tuned for more upcoming videos. Thank you.